everyone, and welcome to the short lecture on naming molecules and acids. Well, I'm also going to talk about formula writing, but we'll get to that. Alright, let's start off with our objectives. You do not need to write this part down, but you do need to write down some notes for the rest of this video. So if you haven't gotten your notes out, go ahead and pause the video and pull those out right now. Alright, so here are our objectives. Red light, yellow light, green light. I can correctly identify the three main types of compounds based only on the chemical formula. I can correctly go from the formula to the name for all the three main types of compounds based only on the chemical formula. And then the last one, I can correctly write out the formulas given the names for each of the three main types of compounds. So I want you to be able to look at a formula and get its name. I want you to be able to look at the name and get its formula. And we have been concentrating very hard on ionic compounds, but now we're going to move on to the last two, covalent and acids. All right, so here we go. So let's review a couple concepts that we did discuss in class today. One of the biggest things that we discussed, and I said this is super important, ionic compounds are a combination of metals and nonmetals. Covalent compounds are all nonmetals. And now, the third one, we have acids. So, acids have all nonmetals, but when we look at the formula of an acid, they're always going to have the hydrogen in the formula written first. So you know how like in ionic bonds, we always write the metal first? Well, in acids, we're going to write the hydrogen first. Alright, and then I always get asked this, what do we call acids? Because acids are going to have a hydrogen ion in the front, with a nonmetal somewhere in the back. So remember, nonmetals, there's very few of them on the periodic table. But you will always see the hydrogen in the front, and so a bunch of nonmetals in the back. So technically, isn't that a molecule? And I say, well, yeah, technically, they are called covalent compounds. But remember how we talked about how bonding, it's on one side you have covalent, and on the other side you have ionic? Alright, well, you know about how we have polar, kind of in between covalent and ionic? Alright, well, acids are typically in between. Some of these acids are actually really close to being considered ionic. And so anyway, we'll talk about that in a little bit. Okay, so let's get started. This is a review for most of you. You probably heard of this before. Mono, di, tri. But now I got to kind of extend that, so you do need to write this down. Mono is 1, di is 2, tri is 3. But now we've got tetra, penta, hexa, hepta, octa, nona, and deca. I want you to know all of those prefixes up to 10 because that's going to help you here in just a minute. So pause the video here, make sure you get all of those prefixes. Alright, let's go to the naming molecules. Here we go, naming molecules. There are 3 rules when you name a molecule. And when you write these down, you're going to be like, what is she talking about? Just write it down and I'll show you what I mean. So, rule number 1. The name of the first atom in the formula only gets a prefix if there is more than one present. Rule number 2. The second atom in the formula always gets a prefix, even if there's only one. And then rule number 3. The last atom, or the second atom, in the name of the molecule, that name must end in an "ide." So get those 3 rules. Pause if you need to. Write it down. Here we go. Here are some examples. Alright, so in the first example, you have just carbon with 2 oxygens. And the rule said that the first atom in the formula only gets a prefix if there's more than one. So you notice here I didn't say monocarbon, it's just carbon. Well, the second atom in the formula always gets a prefix. So how many oxygens do we have? Well, we have 2. And you'll notice that I put a di in the front. And then you know that that's oxygen, right? But rule number 3 said that the end of the name must end in an "ide." So you see carbon, di, ox, not oxygen, but dioxide. Let's go to the second one. Very familiar to you. You can call this water, but it does have a technical name. So let's get to it. The first atom only gets a prefix if there's more than one. Well, there is. That's why you see di. Now, the The first atom does not end in an "ide," so we're going to say dihydrogen, just write out the name of the atom. But the second atom always gets a prefix, even if there's more, or even if there's only one. And there's only one present, so we're going to say mono for one. We're going to say ox, and then it will end with an "ide." Now, I always ask those, I have some students that are really observant, and they're like, "Hey, man, didn't you say you have to have a mono? And then wouldn't we say ox and then "ide"? All right, you see how there's two O's present there? That would be monoxide. All right, just chop one of those O's off and call it monoxide, okay? All right, let's go to the next one. First atom only gets a prefix if there's more than one. There isn't, so we're just going to say phosphorus. All right, the second atom always gets a prefix. The prefix for 4 is tetra. And this would normally be called fluorine, but we're going to change it to fluoride. All right, let's do the next one. First one always only gets a prefix if there's more than one. So there is. So we're going to put the di. Disulfur is the name of S. This guy always gets a prefix, and there's 6. So you're going to see the hexa, and it isn't oxygen, but oxide. All right, let's see if you can do it now. So the first atom only gets a prefix if there's more than one. Well, there isn't. This guy's name is phosphorus. The second one always gets a prefix. So the prefix for 6 is hexa. And this is called chlorine, but we're going to say that's right, chloride. So phosphorus hexachloride. Let's do the next one. First atom only gets a prefix if there's more than one, and there is. So this would be disulfur. And the second one always gets a prefix. This is tri for 3. Tri, not bromine, but bromide. You got it. Next one. First atom only gets a prefix if there's more than one. There isn't, so I'm just going to say nitrogen. Second one always gets a prefix. That is tetra. Tetra, not chlorine, but chloride. You got it. Okay, let's keep going. The next compound that we're going to discuss is how to name and to write acids. All right, there are 3 rules for naming acids. And the name of the acid actually comes from whatever the name of the anion is. Interesting. You know how I taught you that ions that come from the periodic table, they end in an "ide. Anything that ends in an "ate" or an "ite" comes from your list, right? So these 2 right here are polyatomic, and this one is usually polyatomic. Remember, we have a couple exceptions. It's hydroxide and cyanide. Okay. All right, so the name of the anion actually determines the name of the acid. So when you look at the anion that the acid was made with, if the anion ends in an "ide," the name of the acid will have a hydro in the front. That's called a prefix. It'll have a hydro prefix, and then it'll end with an "ic." That's called a suffix. So it'll have a prefix of hydro and a suffix of "ic." And the middle part, some people call this the base of the name of the polyatomic ion or monatomic ion. So whatever the base is, you stick that in the middle. All right. The next one, 8 ions, they have no prefix, but they need to end with an "ic." That's a suffix. And then you just call it an acid. And then the last one, ites. Ions that end in an "ite," you have to change the end to an "us." Change the ending of the ion's name to an "us," and then say acid. All right, pause here if you need. And here we go. Make sure you write that down. So let's get some examples. Hydrochloric acid. So you just wrote down the rules, right? Look at those right now. So which rule would have a hydro in the front with an "ic" at the back? That comes from ide ions. So this piece right here, chlor, that would be kind of like your base. So the name of the ion that hydrochloric acid uses, the name of the ion is chloride. That's the name of the ion. So now you really have to depend upon those rules that I told you. Any ion that ends in an "ide" comes from the periodic table. Anything that ends in an "ate" or an "ite, you would have to use your polyatomic ion list. Okay? So chloride is Cl with a -1. You would have to be able to predict its charge since it's monatomic. If it was polyatomic, you just look on your list. And acids are made with hydrogen ions. And remember how I told you to identify acids, the hydrogen is always written first in the formula. So when you look at the formula of hydrochloric acid, it's just HCl. Now I want you to notice something. Hydrogen ions are always positive 1. Do you have to balance charges on acids? Yes. Yes, you do. So guys, if this was actually a negative 2 ion, you would have to put 2 hydrogens in the front. And I'll show you some more examples. Let's do the chlorus. Chlorus ends in an OUS. There's no hydro in the front. Okay, there's no hydro in the front. So you would have to figure out what ion made chlorus acid. Chlorus is made with ite ions. So you should be looking for here's your base, chlorite. Chlorite, ending ite, is polyatomic, and it does come from your polyatomic list. Chlorite has a negative 1 charge, so we would put 1 hydrogen in the front, and there's the formula of chlorus acid. Let's do it again. Chloric acid. Notice there's no hydro in the front, but there is an ic. Look at your rules for naming acids. Ic acids come from 8 ions. So you would go to your list, because there is an 8. You'd go to your list and find the formula for chlorate. It has a negative 1 charge, so you would only stick 1 hydrogen in the front. Alright, more examples here. Let's do it. Here are some formulas and here are some names. We're going to go from the formula to the name and from the name to the formula. We're going to go both ways. Alright? So when you're naming a compound, all you have to do is just ignore the hydrogens in the front and look at the ion that the hydrogen is attached to. We need the name of the ion so that we can name the acid properly, right? So what is SO4? Well, it's polyatomic, so you would look on your list. SO4 is called sulfate. That's the name of the ion. Well, 8s make a special type of acid. Which acid do 8s make? 8s make ic. So we would call this sulfuric acid. Now, some people say, hey, wait. Wouldn't it just be sulfic? All right. Anytime the name of the atom is like a sulfur, let's see, there's 2, sulfur and phosphorus. You got to keep the in there. So we wouldn't say sulfic or phosphic. We would say phosphoric, sulfic. Or I'm sorry, phosphoric and sulfuric. So keep the sound anytime it's present. All right, let's do the next one. Ignore the hydrogens. What's the name of this ion? Well, if it came off the periodic table, we would call this sulfide, right? The ide. All right, ide ions, they're special. They have that hydro in the front, and then they have the ic at the back. So we would keep the sound again. So this would be, hydrosulfuric acid. That's what we would name. Oh, by the way, I forgot to put the word acid back there. There you go. All right, another one. Ignore the hydrogens. What's this guy's name? He's polyatomic. This is called sulfite. Ite ions turn into us. All right, so what would that look like? That would be sulfurous acid. So there's all the 3 types of acids that you've got there, okay? We got an ic, we got the hydroic, and then we got the us. All right, now let's do some formula writing. Okay, when you first look at this name, oxalic, this is oxalic acid, and when you first hear that, you're like, oh dear, what's going on? I've never heard of this ion before. Okay, you need to remember your rules. Ic acids come from 8 ions. I will never trick you. This ion does exist. Oxalic acid comes from oxalate, and it is on your list. Oxalate looks like this. C2O4 with a -2 charge. Okay, oxalate. All right, so when we make the formula, remember we're going to have the hydrogen in the front. But the thing that you have to remember is that each hydrogen is only a positive 1. So if you have a negative 2 ion, when you make the acid, you gotta put 2 hydrogens in the front. Whatever that negative charge is on the ion, that's how many hydrogens you're going to need in the front. Okay, let's do the next one. Dichromic acid. And you hear this di and you're like, what the heck? Alright, well, I want to make sure you don't get confused. Acids can only have, oops, sorry, hold on, I'm trying to grab the pen. Okay, acids can only have an ic, a hydro-ic, and an us. Okay, so this di must be with the chrome piece. Alright, so the ic acid is still going to make an 8 ion. So there must be a dichromate ion somewhere on your list. Oh, come on. Okay, and sure enough there is. If you look at the list, there is a dichromate. You just have to find it. It looks like this. It's a Cr2O7, and this guy has a negative 2 charge. Alright, just like you did here, how you had to use 2 hydrogen ions in the front, you're going to have to do that again. Because remember, hydrogen is only positive 1. So we're going to need 2 of those to balance out that negative 2 charge on the dichromate. And so there you go. Let's do the last one. Phosphorus. Okay, us acids come from ite ions. So we should be looking for phos, you know, that or part that I was talking about. We should probably be looking for phosphite. And sure enough, an ite ion does come from your polyatomic list. Phosphite is PO3 with a 3- charge. Alright, so now how many hydrogens do you think you're going to need? Each hydrogen is positive 1. Alright, so that means you're going to need 3 on that. I hope that made sense for you. Now you know how to do acids and molecules. Holla! Obviously you're going to need some more practice. And don't worry, practice is coming. If you still have your packet, the big old packet that has the formation of a salt lab on there, on the very, very back, there's a study guide already ready to go. You've already got your study guide for this unit. Woot woot. But you also have the Practice It All worksheet. The Practice It All worksheet mixes up ionic compounds with acids, with molecules. They're all on there. And remember, the most important thing is that you need to be able to correctly identify what kind of compound you've got. Ionic compounds have a metal and nonmetal. Covalent compounds, molecules, have all nonmetals. And remember, acids have a hydrogen in the front. Now, in the name, the first word that pops up, if it's a metal, if that first word in the name is a metal, well, you're ionic. Okay? If you hear any mono or di in the name, you know you've got molecules. And then, of course, if you see the word acid, you know you've got an acid, so that's easy. Alright, so I'm going to go back to your objectives. I want you to report out this time. Maybe make a note of it in your notes and give me some feedback when you come back next class. Tell me how you think this vodcast did. Tell me if you think that you understand it well. Can you correctly identify the 3 main types of compounds based only on the chemical formula? Can you correctly go from the formula to the name for ionic, molecule, and acid? And the last objective, can you correctly write out the formula given the name? Wait, oh dear, that says the same thing, doesn't it? I just now realized that. That's hilarious. I want you guys to be able to go from... Oopsies. My bad. I want you guys to be able to go to the name given the formula. Jeez. Okay. Alright, well you get the drift. Now it's time to switch over to the video that I wanted to show you about how bonding is a spectrum. And I will give you instructions after the video on how to post your response electronically on the class website. Alright, so switching gears here, let's go watch that video.
An atom attempts to attract electrons toward itself when bonding with another atom. The level of attraction of each atom is called its electronegativity. When sodium and chlorine react, the chlorine atom removes sodium's valence electron and becomes a chloride ion. The less electronegative sodium atom cannot compete for electrons and becomes a sodium ion. The attraction between the ions is an ionic bond. When bonding atoms have nearly equal electronegativities, neither can attract electrons away from the other. In a carbon-sulfur bond, the electron pair is shared almost equally between the two atoms, resulting in a covalent bond. When hydrogen and oxygen react, the more electronegative oxygen atom cannot completely remove an electron from hydrogen. The shared electrons are attracted more to the oxygen than to the hydrogen atom. This unequal sharing is called a polar covalent bond. Polar bonds have a slightly negative and a slightly positive end.
Now we can study these using a graph like this, where we put potential energy on one side and then we put internuclear distance between the two. So let's start with hydrogen, or H2. If we have two hydrogen atoms together, as we move them really close together, they're going to want to push on each other. In other words, there's going to be repulsion. As we move them farther apart, eventually they're going to get into an area where there's this sweet spot between attraction, and then as we move them really far apart, they're going to be so far apart that Coulomb's law says there's not going to be a great enough force to pull them together. And so if we're below this line, it's attraction, but what we'll find is when we have the perfect distance apart, we're going to reach what is the bond energy and the bond length of those two atoms. In other words, bond length is going to be how far generally hydrogen atoms are going to stay apart, and bond energy is how much energy would we have to put in to actually break that hydrogen apart. And so this graph is incredibly important. When we're looking at non-polar covalent bonds, what we're going to find is that their electronegativities are different. So this right here would be hydrochloric acid. If we look at chlorine, 3.16, and hydrogen, 2.20, there's a difference between those electronegativities. And so the chlorine is actually going to be a negative charge, and the hydrogen is going to have a positive partial charge. Or if we look at water, oxygen at 3.44, hydrogen at 2.20, and so the oxygen is going to pull those electrons closer to it, so you're going to have a partial negative charge here and then a positive charge out here. And that really allows us to have water attracting to hydrochloric acid. There's going to be a dipolar charge, and the connection between those two would be intermolecular at this point. And so how do you figure out what type of bond it is? Well, there's one quick way to do it. You could just look at their electronegativity differences on.
Okay guys, so just one final reminder. On that one video with Bozeman Science, did you notice that his electronegativity scale was just a little different than what I taught you for the difference between ionic and polar? Well, if you have people like this talking about how the range of electronegativity values can change, look at this guy. This is what he considers to be ionic, is when it approaches greater than 1.7. And this guy actually says, no, 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 ionic is 2.0 or higher. So just the fact that there is a discrepancy out there, that should prove to you just how much the idea of bonding and the clear line between ionic and covalent really isn't clear at all. And so when I tell students that bonding is more of a spectrum, I hope now you understand that there is no black and white. There is black, gray, grayer, and so just understand that there is a range in what we call ionic and covalent, and in between ionic and covalent is this idea of the polar bond. Alright everyone, now I'm going to show you how to reply online to that forum that I created. Okay, I've already tested the forum here, and I've already created a response. Once you, when you first go to this, when you guys first go to this, you should see a little button that does say reply. So you're going to press that little button, and it will give you a space to create a response. So when you first click on that, you should be able to see something that says topic or subject line or something like that. what I'd prefer you to do on that particular spot is try to be creative. Talk about something that surprised you about the video, something that maybe you have a question about on the video. So when you create your discussion here, what I want you to do is, first of all, don't be too wordy. We don't want you to write like a book here, okay? I'm expecting probably about 2 to 3 sentences of a response specifically about these 2 videos right here. Was there something that surprised you, something that you have a question on, something that you'd like to see elaborated, something that interests you, or any of the above, anything that you want to discuss. And please remember that when you write a response on this, that you need to mind your what I call etiquette, but I change it to say netiquette because you're on the internet. So mind your netiquette. In other words, don't cut anybody down. So mind your manners. And when you reply, typically in a conversation, you always want to try to acknowledge what the other person said somehow, and maybe extend on that. So one of the things I want you to do is to post something original, post something that you have to create, and then go back, and this might take some time, but go back and reply to 2 different people's posts. All right? And this assignment, the way it works is that it will be marked complete. It'll give you like a little check mark of completion once you have done both a post and 2 replies. Okay, so that's your homework assignment, and that'll be due by next class on the 21st. All right, everyone, I hope this helps, and I'll see you next time.